So in part one of this lesson, we went through this example right here, and we saw what the total area was and what the signed area was for the regions bounded by these lines and the graph. And we saw that we had a part of the area above the x-axis and a part below, and that impacted our answer and how we approached things. So let's just go through some key points before we move on. The first thing being that if we find the definite integral of f of x between these intervals, this is going to give us the signed area enclosed by the graph and the terminals. So that's what happened when we took the integral between 0 and 3 here. We really paid no respect to the fact that some of our area was above and some of it was below. So that means we winded up with the signed area and not the total area. So if we come down and read some more definitions here, it just tells us that regions above the x-axis have a positive signed area, while regions below the x-axis have a negative signed area. So this means if you want to find the total area of the shaded region here, what you're going to have to do is add together the area, so the absolute values of all the a's here, so a1, a3, a4, you'd have to add them together. But if you want the signed area, you're more or less just going to add them as they are, knowing that a2 is going to be negative and a4 is going to be negative, as you can see right here. So knowing the difference between the total area and the signed area is very important. Okay, so let's now do another example, and you're going to see how this plays out. So what we're being asked here is to find the area bounded by the graph y equals x squared plus x, y equals 0, and x equals 1. Now, before we can solve this, we have to figure out what is above and below the x-axis, which areas. So to do that, we're actually going to have to graph it. So let's begin by graphing what our function is going to be. In order to do that, we're going to have to find our x-intercepts. So to find our x-intercepts, so to find x-int, we all know how to do this. We're going to let y equal 0. To find x-int, let y equal 0. And we're also going to factorize to solve for that x. So we're going to get 0 is equal to, I'm going to take out my common factor of x, which is going to leave me with x plus 1. What I now do is use my null factor theorem, which says I'm going to set both of these equal to 0. So I'm going to get x is equal to 0 for this one, and x plus 1 is equal to 0. So therefore, my x-intercepts are going to be 0 and negative 1 based on these. So I'm going to come over here and say, well, here is negative 1, here is 0. Now I know that this is going to be a quadratic because I have a squared. So, and I also know it's going to be upright because my x squared is positive. So we can draw this very easily by just looking at our x-intercepts and giving it a sketch. It's going to go through those points. It's positive. It's going to look like this right there. Perfect. Having done that, we now need to draw in our other points. And just so you know, I didn't do it because I didn't have to, but if you wanted to, just for completeness sake, to find y-int, let x equal 0. This was kind of be redundant because we have already done this. We would be left with y is equal to 0 squared plus 0. Y is equal to 0, 0. So I wasn't skipping that step. I just realized straight away that my y-intercept is just going to be 0. So let me just write that like that. My y-intercept is just going to be 0. Okay, having done that, let's now graph y equals 0. Y equals 0 is merely the x-axis. So it's just going to be the line that goes through this right here. So let's put in that is y is equal to 0. This is y is equal to 0. And the other one that I have is x is equal to 1. So let's put that one in as well. So I'm going to come over here and I'll draw that in. It's going to look, oh, let me draw this nicely. It's going to look something like that. Let's hope that it doesn't have to be the scale here. We just have to make sure that it makes sense. So this will be 1. This is going to be x is equal to 1. So having now drawn that, let's shade in the region that we're trying to find. So we're trying to find this area right here. So the area below the graph there, and the area which is going to be above the graph here. Now, why was it so important that we first sketch it and figure out what is above and below? Because remember, we're going to get signed areas. So if we want to find the total area, which is what the question is asking us, to find the area bounded by the graph, it's asking us to find the total area, we're going to have to take that into consideration. So let's label this as A1, and let's label this as A2. 2. Let's now come over here and do some maths. To find out what A1 is going to be, we're going to find the integral of 0, because that's my bigger value, and -1, that's my smaller value, for the function which was x squared plus x dx. But here's the important part right here. Because A1 is below my x-axis, I know that it's going to be negative. In order to I get a positive value for it, I'm going to put a negative there. And that's going to counteract the negative that I know is going to be produced because it's below the x-axis. So we're just going to make sure we keep that there always. Having done that, we're now going to go like this, put that there. This is going to end up being x cubed over 3 plus x squared over 2 between 0 and -1, which means I'm going to get A1 is equal to, don't forget that negative here. Now I'm just going to get a 0 at the first one. I think you would all agree. If I put that in, I'm just going to get 0 minus, and let me put this like that there as well, because remember there's negative that's affecting all of this. Now I'm going to sub in my -1. So it's going to be -1 cubed, which will just be -1 over 3. Then -1 squared, which will be +1 over 2. Put that in brackets, put that in brackets again. So my A1 is going to be equal to negative. This is where people make mistakes with the negatives. Then I'm going to get -1/3 plus 1/2. So I'm going to get -2 over 6 plus 3 over 6. I think that's the right amount of brackets. So that means I'm going to get A1 is going to be equal to negative. This is going to end up being 1 over 6. And because I've got two negatives there, they're going to cancel out, and I'm going to end up with a positive. And that's exactly what I wanted, because remember, I put in this negative at the start. So if I didn't put in that negative, I would have ended up with -1 over 6. And I could have easily changed that to +1 over 6, knowing that it's below my x-axis, but I just did it at the start because I wanted to. Okay, there we go. Having now found A1, let's now find A2. So we're going to come over here, and how are we going to do this? Can I scroll? I can't scroll across. I'm going to do that, and we'll scroll across, and let's see if I can do it this zoomed out. So I'm going to find A2. Whoops, my computer's just freaking out a bit. I'm finding A2, which is going to be the integral between 1 and 0 of x squared plus x dx. So A2 is going to be equal to, let me do this one step up, A2 is going to be equal to, and now I know that this is positive, so I don't need to put a negative out there because it's going to give me a positive answer anyway. So because I know it's above the x-axis, I know it's going to be positive, so I don't have to put a negative there. I then will anti-differentiate it, x squared over 2 between 1 and 0. So now I'm going to get A2 is equal to 1 over 3 plus 1 over 2. And then I'm going to subtract 0 from it. So what I'm going to be left with is 1 over 6. Sorry, I'm going to be left with 5 over 6. So because 1/3 will become 2 over 6, and this one here will become 3 over 6 once I give them common denominators. So that means A2 is going to be 5 over 6, just like that. So let's highlight that. Now what I'm going to do to find my total area, so I might do this in green, to find my total area, I will plus together A1 and A2. So total area is going to be equal to A1 plus A2, which is going to be, if I scroll down a little bit, 1 over 6 plus 5 over 6, which is going to be equal to 6 over 6, which is going to be equal to 1. Hooray. So notice that we found the total area. We did not find the signed area. If we did find the signed area, let's do that as well. So a question might ask you this, what is the signed area? To find what the signed area is going to be, I'm going to realize that this right here, because it's below my x-axis, is negative 1 over 6. This is going to be positive 5 over 6. So when I sum them together, what I'm going to be left with here is 4 over 6, also known as 2 over 3. That would be my signed area. But by the wording of the question, it was not asking for the signed area. It just asked us to find the area bounded by the graph. So that means what it was asking for was the total area. And with that, I will bring this question to a close. In the next video, I'll go through the next question down there. Hopefully all this made sense, and I'll see you soon.